Newton's Law of Motion for second graders by Sonia Ambris Garza and Hania Espinosa. Since me and my partner went to the same school and we were experiencing the same grade as the teacher, we decided to do our lesson plan as a second grader teacher. What is motion and who is Isaac Newton? We found this in the children's book, so it's easier for them to understand and with words that they can comprehend. So, for what is motion, the book told us that motion happens when something moves from a place to place. The earth moves around the sun. People move while working and playing. Animals swing, fly, or walk from place to place. Machine parts move back and forth to do work. And for who is Isaac Newton, since this presentation is all about the Newton's law, we also put who invented it or who he discovered it. Isaac Newton was an English scientist in the 16,000. He studied how things move in 1687. Newton wrote these laws about motion. These laws are called Newton's law of motion. This is a simple way for the students to understand. In simple words, we're going to be describing what Newton's first law is. So, the law tells us that an object is not change its motion unless acted upon by force. If something is sitting still, it wants to stay still. If something is moving, it wants to keep moving unless something stops it. If you slide a toy car on the floor, for instance, it will continue to go until it strikes as well as on a wall or the floor, which will slow it down. For example, your body feels as though it wants to continue moving ahead when you're in a car and it stops suddenly. According to this law, unless anything pulls or pushes on something, nothing will change. To demonstrate this law, we made a simple activity that the second graders can be doing. So for activity 1, so they can learn Newton's first law, we're gonna move the toy car along a flat surface and track how fast it goes before coming to a stop. We're gonna talk about how it continues to move unless something stops it, like friction. So the materials you're gonna need for this is a small toy car, a flat surface, like a table, and a stopping object, like a book or a box. In this case, we use a color box. So for step 1, you're gonna gather your materials and push the cars in a flat surface. Step 2, you'll see how the car that has a stopping object will come to a stop due to the friction of the object, while the other car will continue going until friction stops it. For activity number 1, we're going to talk about Newton's first law, where it tells us that an object will not change its motion unless acted upon by force. We're going to need 2 cars like this ones, a flat surface like this table, and something that would act as our stop of force. Like in this case, it's going to be this box of crayons. We can see if we put this car, we push it with force, it doesn't stop. But if we put something that stops its motion, like this box of crayons, we can see how the car eventually stops.
Second law. This law tells us that the heavier objects need a larger force to move them. As an example, a light ball will roll quickly if you push it. However, unless you press significantly harder, just like way harder than you first did, a large heavy ball will not move at all or as quickly. Therefore, the law clarifies why heavier and larger objects require greater force to move. Another example for you kiddos is if you see a small little tiny ball and you flick it, it moves really fast. But now imagine if that was a bowling ball. If you flick it, you'll probably hurt your finger and that ball will still be in the same position. Don't flick a bowling ball. But if you push a bowling ball harder, it will roll. Activity 2. In this activity, we would use the same amount of force to push various balls and track their distances. We will talk about how it takes more force to move the heavier balls. For this material, we will need at least 2 balls of different sizes and weight. For step 1, after gathering balls from different sizes and weight, push them with the same force. Don't use more force on the others, push them all the same amount of force. Step 2. You will see how the heavier ball will need more force to travel the same distance. Step 3. After you push with the harder force, you'll see how they finally travel with this ball had done without that much force. So, this ball, I'm not sure you see it, is small. You don't really need to push it that hard because it's a small little ball. This one is a really heavy ball. So, this one will need more force to be pushed, and this one will not.
For the second activity, we're going to be talking about Newton's second law of motion. This tells us that the heavier an object is, the more force you need to apply to push it. In this activity, we would need at least 2 balls, but in our case, we have 3. This is the lightest one. This is the one in the middle. And this is the heaviest one. So using the same force, I'm going to push all the balls. That one moves. That one moves a little bit. And this one stays in the same place. So since they're heavier, we're going to use more force to move them. And since this is the heaviest, you need to use a lot of force to move it. Since they're different weights, you need more force to move the heavier balls and not as much force to move the lightest. For the second.
Lastly, we're going to talk about the last law that Newton invented, Newton's third law. This law tells us that for every action there is an equal and opposite reaction. This means that if you push or pull something, it will push or pull back with the same amount of force in the opposite direction. When you jump off a swing, for instance, your feet press down on the swing, you are at once moved into the air by the swing. Another example is when a balloon is blown up and released. The air that rushes out pulls the balloon in the other way. As a result, anytime you push or pull something, the object immediately pushes or pulls away. This is the example we're gonna be demonstrating with a video of a source we found.
Activity 3. For this activity, we will attach a blow-up balloon to a straw after inserting it through the string. We will watch as the balloon zips across once you release it. We will talk about how the balloon moves to the opposite direction due to the air being pushed out. The materials you'll need is a balloon, string, tape, scissors, and a straw. Make sure the scissors are safety scissors or have an adult present with you to help you. Step 1. Attach the string in the anchor point and pass the string through the straw. You will need a little bit of patience with this if you're not really good coordinated. Step 2. Add tape to the straw and blow up the balloon so it can get attached. You could blow up the balloon as small or as big as you want, doesn't really matter. You'll get the same results. Step 3. See how the balloon moves to a different direction because the air is getting pushed out.
Today, I'll show you how to make your own balloon rocket. For this, we'll need some tape, a balloon, a straw, scissors, and fishing line. First, find an anchor point for your fishing line and tie it on. Then, measure it out to another point in the room. Then, cut it with your scissors. That will be your launch point. Next, cut the straw in half and thread it onto your fishing line. Then, blow up the balloon and tape it on, like this. Finally, grab the other end of your fishing line, take a few steps back, and let go. Launching in 3, 2, 1. The balloon is pushing out the air, and the air pushes back on the balloon, causing it to move in the opposite direction. That's Newton's third law. Try blowing up the balloon bigger or smaller, or making it heavier. See what happens. Try it yourself.
In order for the second grade students to understand this lesson on Newton's 3 laws of motion, they will need to know these next 6 words. It is important that they know these words because these words will keep on coming up on the lecture, and we need to ensure that they know what they are, so we won't have to stop and repeat it every single time. Number 1 is force. Something that changed the speed, direction, or motion of an object. Number 2 is friction. A force produced when 2 objects rub against each other. Friction slows down objects. Number 3 is law. A statement in science about what always happens when certain events take place, like Newton's laws of motion. Number 4 is opposite. Facing or moving the other way. Another way, excuse me. Number 5 is reaction. An action in response to something that happens. Number 6 is speed. How fast something moves. Speed is measure of the time it takes something to cover a certain distance.